type of variation. It's a simple one. It's called direct variation. You'll see it in word problems. The variables directly variant or varies directly. Depends on the order. It really doesn't matter. As long as they have those two words in it, there's a standard setup. Now, this is not what you write down for every problem that says direct variation. This is what's just called a standard setup. And the standard setup is some variable. It doesn't have to be y. What you're going to want to do is replace the letters with things that represent the words in the problem. But sometimes they'll use y. You're going to have this k, and k is actually the only letter that you use throughout variation. Any type of variation is going to have a k. I'll tell you what it is in a second. And then we're going to have x. Now k is called the constant of variation. It is there to establish a balance between x and y. Now, why is it called direct variation? Well, it's pretty easy to figure out. As x gets bigger, what happens to y?
It's bigger also.
It's going to get bigger also. And as x gets smaller, y is going to get smaller. So they vary directly. As one gets bigger, so does the other. As one gets smaller, so does the other. Direct variation. Oh, the amount of gas you put into your gas tank. The more you pump in, the more it's going to cost you. And that constant of variation in that terms would be how much the gas costs per gallon. So that's a direct variation, simple example. So let's do a simple problem. It's number 6 out of the book. And I'll just read it to you. If y varies directly with x and y equals 30 when x equals 18, find y when x is equal to 120. Now, when you read this whole problem, you have to realize that there's 2 parts to the problem, and you have to be able to mentally separate them away. There's the first part that tells you the 2 variables, the x and the y. Now, that first part is just so you can solve for the constant of variation. For instance, they could tell you that you spent $50 on gas by buying 10 gallons of gas. K would be how much does the gas cost per gallon. So that's pretty much what the first part is talking about. So when you're looking at number 6 on page, what is this, 404? If y varies directly with x and y equals 30 when x equals 18, find y when x is equal to 120, what's the first part? It's all one huge sentence, but what's the first part? The 18 and 30. The 30. So you separate it there and you talk about that 18 and 30, and you ignore completely the x equals 120, because you don't care about that part now. So write down the info from the first part. Well, I know that x is equal to, I forgot, 18, and y is equal to 30. So that's just part 1 of the problem. Second part, or actually third piece up here, set up the variation by format. Well, this is saying that y varies directly as x. So the format is going to be literally y equals kx. So underneath this, we're going to write y equals kx. Okay. Now, when we plug in x and y in this case, what's the only letter left over? K. That's that constant of variation. We need to find that constant of variation first. So you substitute into y, you substitute in for x, and you solve for k. I mean, these problems are actually very simple. It's that you have to set up everything on your own that makes it a little difficult. And a lot of people will take that 120 and somehow force it into this problem. Solve for k, divide by 18. Let's see, that would be k equals 30 18ths. What's it reduced to?
15 ninths. Oh, that'd be 5/3.
5/3. 6 goes into both of them, right? So 5/3. So k equals 5/3. Yay! And then you go to the second part. So we're up to here. We set up the variation by format. We solve for the constant of variation. And now we're going to plug it back into the formula. So this becomes part 2. All of that over there right now is part 1, finding k. Part 2, you start off with y equals, and instead of writing k, you're going to write 5/3. And this becomes our formula. This is actually the formula. Everything else over here was not anything to do with a formula because there's too many unknowns. Now we're down to two unknowns. And the second part says x is equal to 120. And this is the part 2 information. So you plug in 120 for x, and you can solve for y. What's the easiest way to do this without a calculator? For you calculator happy people. 3 goes into 120.
40 times.
40 times 5?
200.
200. So the answer to this question is y equals 200. And that's it. It's a very simple process. They get a little harder as the format becomes different. They don't tell you what the variables are. For instance, number 10. Time of fall and gravitation. When an object is dropped, the distance it falls in feet varies directly with the square of the duration of the fall in seconds. An apple that falls from a tree 1 foot in a quarter of a second, how far will it fall in 1 second? How far will it fall in 2 seconds? Okay. So when an object is dropped, the distance it falls in feet varies directly with the square of the duration of time.
It'll be 8 feet.
Well, what do we got so far? How far did it fall in the first part?
1 foot and a quarter second.
Part 1. 1 foot, quarter second. These are our unknowns later on in our formula. So what do you want to represent 1 foot with? What letter?
Why?
No, you do not want to use y because in your head y could be anything. But read the problem. What letter would you want? I wouldn't want to use x either.
Okay.
No, k is the constant of variation. Like I said, y and x over here are just variables. They can be any letter you want.
FT.
P equals k, q. So what do you want to use for 1 foot? What's it say it is in the problem?
An apple.
No,
A foot.
no.
What did you talk about?
The words that are in the problem, read it. What does that 1 foot represent?
A quarter second.
No, it does not represent a quarter second.
It is what it said.
No, it doesn't. It doesn't represent a quarter second. It
An
says it
apple?
fell a foot in 1 second, a quarter second.
An apple.
Square of
Duration is this. What is this considered? How about that? 1/4 of a second is
Duration.
measures
Time.
time. And what letter does time start with?
T.
T. Great. So this one's going to be represented by T. What do you want to represent 1 foot with? What's it represent?
Distance.
Thank you. So what letter do you want to use? D. Don't get stuck in the x, y thing because once you get down to the end, you're going to say y equals 200 and you're not going to be sure if it's the distance or the time. But if you have d as distance and t is time, then when you get down to the end and you have d equals something, then you know it's in feet. And if you have t equals something, you know it's going to be in seconds.
Why we don't? Isn't it just going to be 8 feet?
No,
It's not.
I don't think so. You want to find out
Yeah.
instead of guessing?
It's gonna be 8
I
feet.
love your guesses, though. All right, so how does D vary with T? You have to read the words. I can't help you unless you read.
What was
How does D vary with T? The distance an object falls varies directly as
the square foot of the duration of the fall in seconds?
the square. It's a square of, not square root, right?
Square of.
Square of. So when you say this, the setup is generally y equals kx, right? But y is getting replaced with d. K is going to be k no matter what. What's x going to get replaced with?
T.
Really? Is that what it says? Y'all don't like reading words, do you? The distance that it falls varies directly as the time.
Fall in seconds. The duration of the fall in seconds.
Go further, back where next to variation.
multiple.
What's it say about time?
You need to look at it.
I'm looking at it. I know what it says by heart. Seconds.
Quarter second.
Oh my gosh.
It says fall.
When an object is dropped, the distance it falls in feet varies directly with the
Square.
square.
I said that a second ago.
Yeah, well, what do you do with it? So what goes here?
Square T.
Well, how do you
T
write
squared?
it? Thank you. Square T. T squared. I didn't hear you say square. Alright, so this is our format. This is the format. It's not a formula until we solve for K. Alright, so part one. How far did it fall and how long did it take to fall down?
It took a quarter second
For how to
for
fall.
1 foot.
So the first part is going to be 1 equals K times a quarter squared. Yeah, try to sneak it, Tori. What's a quarter squared?
Half,
No, it is not.
1/8.
A 16th, right? 1/4 times 1/4 is 1 over 16. So this is 1 equals 1/16 of K. I could use the commutative property there. How do I solve for K? Multiply both sides by 16, and you get K is equal to 16. All right, that finishes off the first part. We found our constant of variation. All right, part two, start all over again, except plug in that K equals 16. So we start with D equals KT squared, but K in this case is 16 T squared. Okay. What does it say after that? The question, the main question is, how far does it fall in 1 second? And you said how far? 8 feet, right?
2 seconds.
Well, it says 1 second first, doesn't it?
Yeah.
How far will it fall in 1 second? So you plug in 1 for T, T equals 1 second, and you get D equals 16 times 1 squared, better known as 16 feet. So after 1 second of falling, this thing is falling 16 feet. Okay. What about after 2 seconds? How far is it going to be falling? Well, it's going to be 2 times, well, 2 squared, which is 4 times 16? 64. So this would be 64 feet. Now, one thing to notice here is after the first second it goes 16 feet. A lot of people would think after the second second it would only go 32 feet. But it's going 4 times as far, which is, that acceleration due to gravity. Things will speed up as it falls until wind resistance kicks in. This is without wind resistance. It's like pulling teeth. Word problems. You have to read all the words.
You have to know what word, understand the word.
You understand the word square, right?
If you say a square T, then maybe you would understand.
Square T doesn't. T squared makes sense. Square
Well,
T
T
doesn't.
squared instead of a square.
But that's the thing. You have to read the words and understand how they relate mathematically. I think the rest of them are. Yeah, I gotta teach you another formula. All right, the other type of variations. Add. There's inverse variation. Or indirect variation is another way of saying it. Varies indirectly or varies inversely. Or indirectly. I've seen both used for both words used. The formula, the standard formula with y's and x's in it, is this, which can also be written as this. Whichever one you're more comfortable with. Most people like the y's and the x's on opposite sides. In science, some of the times they have two quantities multiplying together to give you a constant. That gives you an idea that it's an indirect variation or an inverse variation. All right, so what happens here if we hold k constant and we make x bigger and bigger and bigger? What happens to y? It gets smaller and smaller and smaller. And what happens as x gets smaller and smaller and smaller? Y gets bigger and bigger and bigger. Okay, so that's why it's called inverse variation. Any kind of quantities that are inversely related that you know of? Why do people speed?
To get somewhere quicker.
To get somewhere quicker. So as you go faster and faster and faster, in other words, getting larger and larger and larger, your time is getting smaller and smaller and smaller. So that's why most people speed, but then they don't take into account that it's not a linear operation, it's actually a weird curve. So that's one good formulation. Let's see, that would be set up as time equals distance over rate. As r gets bigger, time gets smaller. As r gets bigger, time gets smaller. Okay. So we should be able to solve some simple problems. Number 12. It's one of those ones that are already written out that you're going to like. And then we jump into an uglier one. If y varies inversely with the square root of x and y equals 2.4 when x is equal to 0.09, find y when x is equal to 0.2. All right, what are the part 1 information that they gave you? What is the part 1 information that they gave you?
2.4 and 0.9.
So y equals
0.09.
2.4 and x equals 0.09. Okay. And how are x and y related in that problem? Keyword.
Square root.
How are they related?
Inversely.
They're related inversely. So the setup is going to be literally y equals k over x. They're not changing from the standard format, except for one problem. That's not exactly right. Why not? If y varies inversely with the square root of x, what's missing? The square root. It has to literally be the square root of x. So there's an adjustment to the original formula. And that's fine. You can adjust it a little bit every which way. The standard setup has to be the same. Plug in what you know. Y is equal to 2.4. K is the constant. Square root of 0.09. What's the square root of 0.09? Close, no cigar. What is it? 0.3. Because when you multiply two decimals with one decimal place each, you get a 2 decimal place answer, right? I mean, if you go 0.3 times 0.3, you get the 9, but you'd also get 2 decimal places. So you have to move the decimal place twice, which would be 0.09. You all remember how to work with decimals, right? But that's it. So this is 0.3, so you get 2.4 equals k over 0.3. How do you solve for k?
Get it alone.
How?
Multiply
both sides by 0.3. So what's 2.4 times 0.3? 72? 0.72. 0.72. There's 2 decimal places, and the product of those is 72, so that becomes, oops, I might as well write that down, 0.72. So that's the end of part 1. When we come back to part 2, I have this new variable that I know. Which one is it, x or y? I forget. X equals
0.2.
0.2. Okay. And our formula now becomes y equals, it's a formula, it's not a setup anymore. K is equal to 0.72 over the square root of 0.2. Now I highly suggest you use your calculator, round to the nearest hundredth. Should be fine. I have no idea what this is equal to. Oh, just tell me.
Round to the what?
2 decimal places, nearest hundredth. 0.45. And you get y equals 0.45. Yay! See, these are not hard, but you do have to read your words very carefully. You do have to separate it into 2 parts. Part 1, solving for k, to create your formula for part 2, which is to solve the entire problem. Let's make it worse. Yeah, that was boring. Ooh, there's one. Number 20. Oh, no, we can't do number 20. Darn it, we'll have to do the boring one. Number 16. Electric current. If the voltage in an electric current is kept at the same level, the current varies inversely with the resistance. The current measures 40 amperes. Do you care about amperes? No, you don't worry about that. That's just how it's measured. When the resistance is 270 ohms, do you care about ohms? No, it's just how it's measured, and don't worry about it. Find the current when the resistance is 100 ohms. All right, so what are we given in the beginning for part 1? Part 1 info? 40 and 270. Now, what does the 40 represent? What does the 40 represent? What's the word associated with it? Well, it's amperes, but that's how it's measured. What does it represent? What kind of measurement?
Electricity.
What kind of measurement in electricity? There's a lot of measurements in electricity.
Amperage.
That's how it's measured. That's like saying feet. But we didn't say it was feet when we were talking about it. We called it distance. So what is 40 amperes? What's it measuring? Okay, read the problem again. There's 2 words in there that are extremely important. Read it.
Current. The current varies inversely with the resistance. The current measures 40, resistance is 270.
All right, so if this is current, what do you want to represent it with?
C.
C. And that's amperes. And this is
Resistance, R.
R. Generally, they use capital R for resistance, not little r. All right, so you get C and R. How is it related? You know? If the voltage is blah, 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 blah. The current varies inversely with the resistance. So how do I want to set that up? The current varies. Might as well just write that down.
K over R.
K over R. So there's your setup. It's not a formula yet because we don't know what K is. All right, so I can plug in my 40 for C. I can plug in my 270 for the resistance, R. How do you solve for K?
Multiplied.
Multiply both sides by 270. What do you get? 1,000? 10,000? 800? That's fine. Big ugly number. All right, now let's set up our formula. So here's part 2. Formula. All right, what's the formula going to look
C
like?
equals 10,800 over 100.
Not over 100. The formula is over
R.
R. You want your formula first because things can change. Your C can change and your R can change. But that 10,800 is going to stay constant. All right, part 2 tells you what though? Find the current when the resistance is 100 ohms. So in this case, R is equal to 100. So we get C equals 10,800 divided by 100. So C equals 108 what?
Amperage.
Amperes. Let's see if I spell it right. H. P-H-E-R. Oh, no. A-P-A-M-E-R-E-S. It's a weird word. That's probably the simplest of
A lot of amps.
nice electric formulas. They're usually nastier than that.
That'll put you down.
What's that?
108 amps.
Depending on the voltage.
The voltage that kills you is the amperage.
Yeah, but the voltage is what's flowing through it. So if you have a low voltage, joint. So joint or combined variation. Joint variation, kind of on its own. The way I've always looked at it is y equals kxz. It adds in an extra variable. The reason the book calls it combined variation is they allow that z to be on the top or the bottom. And that way you're talking about a direct variation and a inverse or indirect variation. So, let's see. As x gets bigger, do I know anything about y?
I guess it stays the same.
You don't know. It all depends on what z is. So if xz gets bigger, then y gets bigger. And if xz gets smaller, then y gets smaller. So it really depends on the product of x times z. So it's not really a indirect or inverse or direct variation. It's a, I don't know, but I have three variables to work with. Remember, k is not a variable, it's that constant. All right, so let's see where they have one of these. Nope. Nope. I don't have very many of this one. Number 20. It's the only one they have. Wind generator. The force on a blade of a wind generator varies jointly with the product of the blade's area and the square of the wind velocity. The force of the wind is 20 pounds when the area is 3 square feet and the velocity is 30 feet per second. Find the force in the area increased by 5 square feet and the velocity reduced to 25 feet per second. All right, what's the part 1 information?
F equals 20, area A equals 3, and V equals 30.
F equals 20. Let me do that. A equals
3.
3. Okay. So you want to use what? V for velocity equals 30. Okay. You took care of two things at once. What's the force measured in?
Pounds.
Pounds, LBS will work. The area is square feet?
Yeah.
Okay, square feet. And the velocity is measured in feet per second?
Yeah.
FPS, feet per second. So what is the setup of the format? Okay. The force on a blade of a wind generator varies jointly. So force varies jointly, okay, as the product of the blade's area and the square of the wind velocity. Product means they're going to be multiplied and not divided. So the product of area and the square of the velocity. What do I write?
It'll be K 3 times 30.
No, not numbers. Format. Format.
F equals
K times
AV.
A V squared. Because it says it's the square of the velocity. Now you can plug in your numbers. F is equal to
K.
20. F directly is equal to 20. We're plugging in now. We got the format. The format is F equals K AV squared. K is what we're looking for. A is
3.
3. V squared, or V by itself is just 30, but then we have to square it. All right, 30 squared? 900 times 3?
2700.
2700. So we get 20 is equal to K times 2700.
Divided by 2700.
Yeah. So you're going to get K is equal to 20 over 2700, which reduces down to 1 over...
So
I'll figure it out in a second. 1350? No, 135. 1 over 135. Okay. So there's K. Now we can come up to our formula, part 2. What information were we given for part 2?
the area is increased to 5 square feet and the velocity is reduced to 25 feet per second.
Okay, so there's the info. What's the formula going to look like? Just the formula without numbers, except for one number. There's the format over here. So what do I do with the format?
F equals.
F equals? But what's K?
K would be 1/35.
1 over 135. A, B squared. So that's your formula. That becomes a formula you can plug into and solve for the unknowns. But of course, you need two numbers to plug in. I can plug in A and I can plug in B. I really shouldn't be using this F. It should be a capital F, but I already wrote it down, so that's all right. F equals 1 over 135. A is equal to 5. B is equal to 25. Don't forget, you need to square it. Oh, calculators. 25 squared is 625. 625 times 5 is, I have no idea off the top of my head. 3125?
Yeah.
Seriously? Oh, that's scary. So F is equal to 3125. 25. But it's over 135. I'm hoping that goes in the
No,
middle.
not 31.
3125. 3,125. Does it go in evenly? 3125 divided by 135? Yeah. What's it come up to? 23.14? 23.14 apples? No, it is not apples. What was force measured in?
Velocity.
No, it is not measured in velocity.
20 pounds.
Pounds, right? So this will be measured in pounds of force. Pounds of force. What's to get? You don't worry about what the formula is talking about. You're not worried how it actually works. What you're worried about is using the first given information to solve for K. After you get K, create a formula. Use the second given information to find their unknown. That's it. You're not worried about what forces, what areas, what velocities. You really care less. You're just plugging in numbers, generating an answer. That's all you're doing.